My name is Joel Skepper, and I'll be your AWS technical trainer for this session, Introduction to AWS Services, Networking, and Security. So if you're new to AWS or just looking to learn more, you're in the right place. Jumping right in, let's talk about networking. At the heart of networking in AWS is Amazon Virtual Private Cloud, or VPC. VPC allows you to create your own virtual private space within the AWS cloud. You can use VPC to logically separate or isolate your workloads, whether you're isolating dev, test, prod environments or separating differing functions due to security concerns. VPC helps you control the flow of your traffic. VPC, like most other AWS services, is logically defined. Therefore, you can deploy as many VPCs as you need for your particular use case. It is not uncommon for larger, more complex environments to have hundreds of VPCs. Ultimately, it gives you control over the network access to your workloads, whether that be public access to the internet or private access only to your on-premises or corporate environment. When deploying a VPC, we must allocate a range of IP addresses. We can then further partition the VPC into something called subnets. This allows us to break our VPC into segments, which we can then use for high availability or security, or apply different controls. The example shown here has a public subnet, which can be accessed via the public internet. You might want to have a public-facing web application here, or maybe a bastion or jump host. We also have private subnets, which do not have direct public internet access. This means they are protected from the bad actors on the internet trying to compromise your application. VPC is what we call a regionally scoped service, meaning it sits across all availability zones within that region. Subnets are availability zone scoped, meaning they sit in individual availability zones. However, you can have multiple subnets in different availability zones in a single VPC. You can have multiple VPCs in the same region, or different regions for that matter. However, you cannot have a single VPC span multiple regions. Amazon VPC also offers connectivity over VPN and another service called Direct Connect, which allow you to connect to your VPC from your data center, offices, or other customer locations in a secure manner. In addition to these hybrid connectivity options, VPCs can be connected to each other, and these VPC connections can span multiple regions. So we have the ability to peer VPCs together to expand our environment if necessary. When we want to control connectivity between these different resources in our VPC, we can configure the routing options on our VPC as needed. The use of route tables, network interfaces, and interface endpoints, for example, give us complete control over the security configuration and connectivity of resources in our VPC. So now that we know more about our subnets, let's talk about how we can take advantage of the different VPC features to achieve a defense in depth approach. When we design our infrastructure, we can achieve defense in depth. What this means is we have multiple layers of protection across the configuration of your VPC. Firstly, we have route tables. One way to protect your workloads is to not allow public internet access or to restrict to outbound requests only. Secondly, surrounding the subnets, we have network access control lists. These are stateless packet filter firewalls that wrap around the subnet and determine whether traffic can enter or leave. These are good for providing explicit block rules to known problem areas or restrict specific protocols or ports. Next, wrapping around the Elastic Network Interface, a virtual network interface that allows the EC2 instance to connect to the network, is the security group. The security group is a stateful packet filter that governs what traffic can enter and exit a specific instance. By default, all traffic inbound is blocked, whilst all traffic outbound is allowed. Lastly, on your EC2 instance itself, you can install your own firewall and protection software. In a small environment where you have a low number of instances, maybe 1 or 2 instances, then traffic distribution is not going to be a problem. But what happens when you want to scale that out? or have dynamic scaling that changes depending on how much load is currently being produced. You need a more sophisticated load distribution method. Bring on the Elastic Load Balancing Service, or ELB. Amazon ELB comes in multiple flavors, but key here is the application load balancer that distributes traffic according to HTTP or HTTPS rules that you configure. Elastic load balancers are highly available and can be used to decouple application tiers. This means your web tier doesn't need to be aware of the changes to the app tier infrastructure. It also supports health checks. So if instances behind the Elastic Load Balancer fail, or maybe your application stops responding, Elastic Load Balancer can actually determine that an instance has failed. It will then stop distributing traffic to that failed instance, resulting in a better experience for your customer. And then finally, we also get security features within the Elastic Load Balancer as well. We can use TLS termination on our Elastic Load Balancer to unburden our instances behind the scenes. The Elastic Load Balancer is regionally scoped. It gives us the ability to distribute incoming traffic to multiple instances or applications in that region. But what if we want to distribute traffic across different regions? Route 53 gives us the capability to do that on a global scale. Route 53 is a highly available and scalable cloud DNS service. You can use it to register domain names and even perform automatic renewals, or configure different routing options which allow us to determine where traffic will go. It provides tools for flexible, high-performance, highly available architectures on AWS, and we have multiple routing options. Let's see how this works. In this example, we have a client or an end user trying to connect to our application that is sitting within our VPC. The end user would navigate to our URL. Route 53 would be used to resolve that into an IP address, which then leads us through our internet gateway to our Elastic Load Balancer, which distributes the incoming traffic to multiple EC2 instances, which could then respond back to the user. And we're doing this all within our VPC, within the AWS cloud. We'll change direction now and talk about security. At AWS, cloud security is the highest priority. As an AWS customer, you'll benefit from a data center and network architecture that is built to meet the requirements of the most security-sensitive organizations. The AWS infrastructure has been architected to be one of the most flexible and secure cloud computing environments available today. A key way to look at security on AWS, especially as a customer, is using this shared responsibility model. When you think about security in your on-premises environment, you need to manage everything, from physical security of the building, to physical security of the IT devices, through to environment controls, operating system, application data, etc. This results in a lot of administrative overhead without much benefit to your business. We previously heard the term undifferentiated heavy lifting, which referred to running the physical components of the data center. When deploying resources on AWS, we learned that AWS took care of this undifferentiated heavy lifting. That is, we manage all the physical stuff for you. This means AWS has some responsibility when keeping the cloud secure. On the flip side, AWS does not have access to your data. We also don't have access to the resources you deploy. So there will be an element of responsibility that falls onto you as a customer. This is where the shared responsibility model comes in. It details and highlights what is AWS's responsibility and what is your responsibility. Let's look at two simple examples. Firstly, when using EC2, it is AWS's responsibility to provide physically secure compute servers that are available for use. When you deploy an EC2 instance, it is your responsibility to apply ongoing operating system patches. It is AWS responsibility to provide the ability to encrypt your EBS volumes. However, it is your responsibility to actually enable the encryption. We don't mandate how you must perform something. We provide you with the options, levers, and controls. In a separate example, let's look at S3. It is AWS responsibility to provide a highly available and durable storage solution for you to use. It is AWS responsibility to provide a permission structure that restricts public access. It is your responsibility as a customer to determine what data resides in S3, whether it is encrypted or not, and which identities have access to it. In short, AWS is responsible to provide a robust and secure cloud framework, a framework that provides you, the customer, the ability to operate safely and securely. It is your responsibility to make use of those configuration options, levers, and controls, to appropriately decide which data can reside where, and then to make informed decisions on how to deploy your services. Every service falls into the shared responsibility model. Some services require more responsibility from you, whilst others require less. There are many services that can help you manage your security, from encryption to key management, to web application firewalls, and logging and monitoring, to name a few. We'll start with authentication and authorization being configured in a service called AWS Identity and Access Management, or IAM. IAM gives you this ability to securely control access to your AWS resources. You can assign granular permissions to users, groups, and roles. You can share temporary access to your AWS account, and also federate users in your corporate network or with an internet identity provider. Let's look at some of the key components of IAM. The core components we'll talk about fall into two categories: identity and permissions. This allows you to decouple or separate the configuration of who or what can authenticate into a given system, and then what they can do once they're in that system. Users and roles are two forms of identity. A user is a permanent identity. You create it and the credentials will stay until you choose to remove them. A role is a temporary identity, which can be assumed for a set period of time, at which point it will automatically expire. A group is not an identity, rather it is a collection of users that makes managing easier. There are two ways a user can authenticate: via username and password into the management console, or via an access key, secret access key, through the CLI or SDK. When you assume a role, you are granted a temporary set of access keys that have a defined expiry. Permissions are granted or restricted via the use of policies. A policy is a JSON formatted document that allows you to grant or deny actions, API calls, to resources. These can be attached to users, groups, or roles. Roles are extremely powerful and allow you to create identity federation, where you can create a single sign-on experience for your users or even customers. So in this scenario, IAM could be used to grant employees and applications federated access into the AWS Management Console and AWS Service APIs by using your existing identity systems, such as Microsoft Active Directory or an LDAP identity store. You can also use SAML-based identity management and even single sign-on for a great end-user experience. IAM also provides the ability to use multi-factor authentication as an additional security feature. We previously talked about S3 for object storage. S3 is an example of a service that can have a resource-based policy attached, in this case, a bucket policy. Let's look at this example where you have created a new bucket. The default access configuration blocks all access other than the owner. Maybe you want the ability to grant permissions to everyone, to make it public. This is useful if you have content that you want to share publicly. Maybe images on your public website, or a new PDF brochure advertising the latest product you're selling. But what if you want to just grant permissions to specific users or services, or maybe a set of users, roles, or services? Bucket policies, along with identity policies we spoke about previously, allow granular control over who or what can access your resources, from where and when. Another way we can ensure the security of our data is to utilize various forms of encryption on objects in our bucket. S3 offers server-side encryption, known as SSE, on objects by either using a customer-provided encryption key, a key managed through the Key Management Service, KMS, or have S3 itself manage the encryption key. Using these forms of encryption enables S3 to encrypt your object when the data is at rest. S3 also supports the HTTPS protocol, which enables encryption in transit. AWS CloudTrail is an example of a service that we can use for security auditing in our AWS account. CloudTrail enables us to track identity activity and API usage in our accounts. We can continuously monitor activities and record API calls against multiple different services in our account. We can use this for compliance, auditing, security analysis, and also for troubleshooting purposes. We can also use this record in case we need to backtrack and understand how access was granted. The API calls are stored in a trail, essentially a log file. These trails can be exported to our S3 buckets that we talked about earlier. And so by keeping all that information, we have the ability to answer common questions from a security standpoint about who made a request, what did they request, when did they make that request, and where were they requesting from, or where did they send or initiate that request. So CloudTrail gives us the transparency in our account, and we can use that from a security standpoint. Additionally, storing the CloudTrail logs into S3 allows us to reduce the cost of storing that important log data, but also grants us the ability to use various querying tools, such as Amazon Athena, a serverless SQL querying tool. The last service I want to talk about in this session is AWS Trusted Advisor. Trusted Advisor is a tool that sits in the background of your account and provides guidance on how to improve your account across various pillars: security, performance, fault tolerance, and cost optimization, along with identifying any service limits you're approaching or have hit. Trusted Advisor bases its guidance on the well-architected framework, a series of best practices compiled by AWS to help build effective architectures. So how does Trusted Advisor work? Let's look at cost optimization. Maybe you have a large EC2 instance, an M5 4 extra large, for example, that has been operating at 10% utilization over the last month. Trusted Advisor may look at this and say, well, you can reduce the size of this instance and still meet performance objectives, but it will cost you less, so you can achieve some savings. On a separate note, maybe you have all your EC2 instances in a single availability zone. If that availability zone were to have an issue, you could potentially lose your entire environment. So Trusted Advisor will give you a warning under the fault tolerance category, suggesting you deploy your resources across multiple availability zones. There are many checks that Trusted Advisor performs, which are regularly refreshed to give you updates and changes to your account and environment are made. I hope you've enjoyed this session and found it interesting. AWS is a data-driven company, and I'd like to take this opportunity to ask you to complete a survey telling us of what you thought of this session. This can help us shape and improve the events and learning in the future. You can also reach out to us on the various social sites listed on the slide. Why not test your knowledge? Make sure you complete the knowledge check after this session to see how you're progressing. Thank you for attending this session.